Hi everyone. We're going to be talking about a new feature in Lilac today that lets you edit data from directly inside of the tool. And so we're going to be taking a look at the Glaive Coding Assistant dataset. Now this is a dataset of question and answer pairs that are meant to be used to fine-tune a model that can help assist with some coding questions. Okay, so we can look at some of the examples here where users ask questions like, how can I output bold text in Bash? And there's some results here. Now in here, there are actually a bunch of Python questions as well, which we're going to try to improve upon. This data set is about 136,000 rows, which is a perfect size for a tool like Lilac. So what we're going to do is we're going to just make this about half the size and go over to our IPython notebook, where I've actually imported Lilac, set a project directory to a folder called data, and we're going to go ahead and just create a data set given this config, which is going to read from Hugging Face, and it's the same data set name as we have on the right. I'm going to go ahead and run that cell. Awesome, we've written the Glaive dataset locally inside of Lilac, and now we can just go ahead and start the web server. So once we do that, we'll get a link here, which will open up on the right. And now we're in the tool of Lilac, and we can click on Glaive on the left and just close the sidebar so we have a little bit more space. And we immediately see that we have the question and answer pairs. Now we could actually go into the fields and just enable Markdown if we wanted to actually see the actual rendered markdowns for some of these results. But for now, we're actually just going to turn this off, and I'm going to show you some other stuff. Okay, great. So what we're going to do now is take a look at some of the examples that actually have some Python in it on the answer side of things. And what we're going to do is we're going to make, this is actually not Python here, so let's keep going. This is Python. We're actually going to try to make a consistent formatting of this Python on the other side so that at the end of the day, our model will have consistently formatted outputs. And we're actually going to use the rough Python formatter to do this for us. And you can already see that there's some strange non-spacing things going on right here, which we'll try to go ahead and fix. Okay, so let's go over to our cell here. And we've written a function called defFormatCode, and its job is to take a row of our data set, take the answer, and this block basically is just calling off to rough, details not exactly important. We're also going to emit a bit for whether we actually made an edit or not. And the idea behind this is that we'll actually use this to be able to filter to the rows that have changed so we can actually visualize the diff on the right. So what we're going to do down here is we're going to call our dataset.map function. And this is the new primitive that we've introduced in Lilac that basically looks like a Hugging Face map where we take a single row of the dataset and we generate something on the other side. But in this case, we're actually going to commit it to the same dataset. In this example, we actually are going to just preview the output just so we can tell that our formatter is doing the right thing. And we'll do this without putting an output column to our dataset.map, and we'll just keep a limit equals 3 just to preview 3 results here. So I'm going to go ahead and just run this cell to show you what it does. And you will instantly see that the 3 results have an answer and it has edit because that's what's coming from our format code. And you'll see that some of them are not formatted. And you'll see that some of them are not formatted. So we're actually going to just increase the limit until we find one that is formatted. And great, we have one that actually has formatting, and we have a printout of the results here. Now, this clearly isn't exactly what we want because this is very hard to read. I can't tell exactly what changed about my data set. So this is where the power of the Lilac UI really comes in handy. So before we do anything, we're actually going to run this map over the entire data set and just commit it to the Glaive data set. And so we can see it on the right-hand side. And so what we're going to do over here is call map. We're going to call our format code function. That's our mapping function. We're going to write it to a column called answer formatted. And now this field will actually commit that column into our data set so we can visualize it. We're going to use numjobs equals -1, which means please slam all of the cores on my machine. And we're going to use an execution type of processes, right? Because this is actually a CPU bound operation. And we're doing overwrite equals true here so that I can run the cell multiple times if I want. I'm just going to go ahead and hit run here. Now what's going to happen is we are going to, I'm going to expand the UI just a little bit so we can see the progress bar. And so once this starts running, which is spinning up on several processes, we're going to see that we have a progress bar that shows up in the UI, and we should have a progress bar that also shows up on our Python side of things. So I'm going to go ahead and just let this complete before we go to the next step. Now, one magical piece of this is that once this map finishes, the UI will just refresh and we'll see the new value for our answer. All right, as we near the end of the progress here, we're going to watch the UI as this task completes, and you will see that it has refreshed. We are actually going to have to go and add the formatted answer to our media fields here. When we come back, we will see that there's another field that looks very similar to our answer field, but it's actually formatted. Now, let's try to figure out what actually changed. And so what we're going to do is we're going to use this button here, which says compare to, and we're going to compare this to the answer formatted answer. And now what we've done is we've actually shown a visual diff of all of the places, and I'm actually going to expand this a little bit more so you can see it, all of the places that we've actually made an edit. And of course, we can arrow through all of the results, and many of them don't actually have edits, but that's where our has edit bit comes in. So we're going to apply a filter for that edit. So we're going to open the schema, and we're going to actually go into this new field that we've created, answer formatted, and under that, there's a bit for has edit. We can see that we've actually edited about 50,000 rows of our 136,000. So I'm going to click on this to filter by it and close this off. And now we're just in the 49,000 results that we've actually made an edit. And I can go through here and I can just check visually to make sure this is what I want. Now, the beauty of this approach is now it combines the Python interface with a visual interface for determining what's actually happened to the data that underlies it. And we may actually not like things like this trailing space here or this trailing space here, and we could go back to the Python code and make some changes and then see the diff again until we're happy. Now, this process is a much better way to understand the heuristics that we apply to data that go into AI systems to get a better sense for actually what we're doing. So this is really just the first step of many of this new paradigm that we're pushing for of text as a programming language. And there are much more features in the future to come along these axes. Now, thank you very much. Look forward to seeing what you do with this.